Hi, everybody. We're going to do problem number 12 right now. This is section 1.1, problem number 12. So they want us to graph the system and solve the system and interpret the answer. And this is kind of like what you did in high school. So we're going to graph this. Well, I don't really have a good graph paper here. So do I have a graph paper? Maybe I do. You know, so I'm going to pause this. Pause. All right, so here's my graph paper. This was the problem number 12 in section 1, and let's graph this sucker. Okay, so I'm gonna go my x-axis, my y-axis. All right, so let's see. So here we have, let's see, x plus 3y. So let's say if y is 0, x will be 2, because that's about right there. And let's see, if y is 1, if y is 1, that's will be negative 1. So y is 1. Oh, that's what it looks like right there. So it looks like we have something kind of like that. All right, and for the other one, let's see, if y is 0, x is going to be positive 3. That's right there. And if, let's see, if y is 1, then x is going to be negative 1. Oh, that's right. That's that point. Yeah. So, yeah, so whatever. Anyway, the two lines are going to intersect right over there at x equals negative 1 and y equals positive 1. Yeah. That's x equals negative 1, y equals positive 1. In other words, the point negative 1, comma 1. Now, on the flip side, if I would just take these equations and add them up, like we typically do, let's say add these two equations up, like we did in high school. So when you add the x's, it cancels. That becomes 5y. And 2 plus 3 is 5. And we divide by 5, we get y equals 1. And once y equals 1, I plug that into, let's say the first equation. So x plus 3y equals 2. So x plus 3 equals 2. X equals negative 1. So the same solution that I got from just doing the high school algebra, I got graphically by seeing with these. There's each of these equations represents a graph, and that's that. We're gonna actually represent these things in this way. Well, you know what? I'm gonna wait till we get to it. I'm gonna show you there's more than one. This is sort of a geometric interpretation of this system of equations. I'm going to show you a different geometric way to look at this, but I have to wait till we get a little bit further on. Maybe we get to like chapter 2. There's a couple of things we have to learn first. Anyway, let's move on to a different problem. I'm going to pause the video. I want to look at number 28 and number 30 right now. Number 28 and number 30. So number 28. I gotta pause the video for a second, and I'll be right back. All right, I'm going to, let's see, I'm going to stop this share. So let me just copy this down here. X minus y equals 4, 2y plus z equals 6, and 3z equals 6. All right, so let me just stop this share. Okay. Well, again, it's very simple because I saw the bottom equation 3z equals 6. So 3z equals 6. That means that z equals 2. Now, once I know z equals 2, we call this back substituting. I take the z equals 2 and I plug it into this middle equation. So we get 2y plus z, but z is 2. equals 6, 2y equals 4, and then y equals 2. And now once I know that z is 2 and y is 2, once I know that, I plug these numbers into the very top equation now. Well, there's no z here, there's y, so it's x minus 2 equals 4, or x equals 6. And now my solution set is going to be 6, comma 2, comma 2. And let's try that. So let's see. 6 minus x minus y equals 4. So that becomes 6 minus 2 equals 4, and that's correct. And this is 2 times 2. This one becomes 2 times 2 plus 2 equals 6. And that's, yeah, 4 plus 2 is 6. That's also correct. And this is 3 times 2 equals 6. Yeah, that's also correct. And it's all good. So now, when you have a system of equations in this way, it makes it much easier to solve. So what we're going to be doing a lot of this semester is taking systems of equations and sort of manipulating them, massaging, manipulating them until we get it to look like this. Because if I have a system of equation, 3x plus 2y plus 4z equals 7, and x minus 2y plus z equals 4, and whatever 2x plus y minus z, whatever, equals 3. I'm just making, I'm just making numbers up. A system that looks like this is going to be a lot more work than a system that looks like this, because once it looks like this, then it's going to be, you're just going to do that. You're going to start at the bottom and just work your way up to the top, and it's going to be really, really simple. You see what I'm saying? So we're going to be doing a lot of this, and this form is we're going to learn. It's in the chapter 1. It's in one of the many chapter 1. It's in one of the videos somewhere that I I'm assigning to you. This form is kind of what they call like a roller form. Anyway, that's enough for number 28. Now I want to go to number 30. Let's look at number 30. So let's share the screen again. And here is number 30. So number 30, if you notice, only has 2 equations. If I'm not mistaken. Here's only 2 equations. Yeah. Nope. How that happened? That's weird. Number 30 is only it's just 2 equations here. I'm gonna write it now on paper. So number 30, x1 plus x2 plus x3 equals 0, and x2 equals 0. Well, right off the bat, x2 equals 0. So that means if I put that into the top equation, I get x1 plus 0 plus x3 equals 0. But now I've kind of gotten this down to 2 equations and 1 variable, two variables in 1 equation, which means there's going to be 1 parameter. Let's just make that x3 the parameter. So if x1, x2, and x3. Well, x2 we just know is x2. We know is 0. There's nothing to talk about. X2, no matter what, x2 equals 0. x3 we're going to call a parameter t, and x1. Well, I know that x1 plus t equals 0. So x1 just equals negative t. So our solution set is going to be negative t, comma 0, comma t. And that is our solution. That is our solution set. That as long as basically what it boils down to, as long as x1 and x3 are opposites of each other, we have a solution. Like I say, x2 is always going to be 0. That has to be, because I would never satisfy the second equation otherwise. So whatever I'm going to have, as long as, let's say it's 5 and negative 5, So you have 5 plus 0 plus negative 5 equals 0. Yeah, that works. So this is my solution set. Now, by the way, another way you can write this, if you want, you can write this as t times negative 1, comma 0, comma 1. Meaning just factor out the t. This and this are two ways. Oh, I don't know this whole time. Should show up. I should have that. You can see it now. Now you see much better. So you can write it this way. You can write it that way. It's two different ways of saying the same thing. We are going to probably going to tend to write it this way more, especially a little bit later on in the semester. But these two are really the same thing. Okay, well, this is all number 30. This was 1.1, and it was number 30. Okay, well, that concludes this video. Of course, we're going to continue with more, and see you guys next time. It's been loads of fun.